patient reflexes, but other things, and also dog physiology and dog medicine, later developed as veterinary neurology of the animal. At the 19th century, Dubois-Raymond from France did enormous contributions to understanding of electrophysiology of peripheral nerve. And at the Museum of Genève, original settings of his laboratory, those stimulation made by these, very big, and the recording chamber. At the beginning of the 20th century, Liverpool, Caton, famous neuroscientist, did more contribution to the picture. He, by himself, developed the evoked potentials, working on baboon, rabbit, and dog. He himself invented the evoked potentials. And he has no computers to analyze these signals. He has only optical magnification techniques. So we have to salute him. As in human, we use electrodiagnostic techniques for disease of peripheral nerve, muscle, and central nervous system also. Many of human physicians did research about the dog as a model for human medicine. Like plastic surgeons, orthopedists, muchly, neurosurgeons, and neurosurgeons, orthopedists, even rehabilitation, models for rehabilitation. We need some models in modern medicine. The same progress is suitable in veterinary electrodiagnostic procedures as in human medicine. We need normative values for laboratories. It should be done by every laboratory for their normative values also. And the literature knowledge about that issue is very limited. Much contribution made by Netherlands, Van Ness. But when you using different species than human, you have to, in advance, to think about the anatomy and physiology specific for this species, whichever you use it. So, neuroanatomy and comparative neuroanatomical studies are very important for every electrodiagnostician, whatever species he is doing. By working with dogs, there are some limiting factors than humans. Like you have to anesthetize the dogs because you can't unrest the animal. You have to use general anesthesia. And some general anesthetics with high doses can interfere with the electrodiagnostic parameters, as you know. We did some search on that research, and a combination of xylazine and ketamine is the best. At this picture, you're seeing rat abdominis muscle with ether, fentanyl, spontaneous discharges, motor sinus and ketamine combination. Sinus and ketamine is the best for this search. Yes. It must be kept in mind that the electrodiagnostic studies are not reliable. So we have to keep do again and again when necessary. And every time, the clinical picture is important for the electrodiagnostician. We not negligible. The clinical picture is not a negligible thing. All the time, the operator, the electrodiagnostician, have to think about the clinical picture. This is our laboratory, and how do we use methods for trying to examine the dogs? As you see, very simple to human, especially children, puppies, like anesthetized dog. It approximately takes 30 minutes to search major nerves to study. Flexor carpi communis here, recorded from the elbow, stimulation from the elbow here, and the sensorial action potential and motor latency. The hair, another limiting factor when you using the animals. Sometimes you have to shave the area, but maybe some shaving problems, contraindications about shaving, and you may have no time to shave the animal. But especially for sensory studies, for clear-cut sensory studies, sometimes we have to shave the area recording side. This is ulnar sensorial nerve stimulation with sensorial electrodes. Plexus brachialis is very important, and every diagnostician should know detailed anatomy of that. All the time, functional anatomy, neuroanatomy kept in mind of the electrodiagnostician like that. In dogs, T2 always muchly in the plexus brachialis. But there are more variations, anatomical variations than the humans in dogs and other related species, canine species, feline maybe. Another picture of plexus brachialis, sharp dissection, and the identification of the important anatomical structures. So, as at the beginning of the 12th century, famous anatomists have said, those who have inspected or dissected many at least learn to doubt, but others who are ignorant of anatomy and do not take the trouble to attempt to it are in no doubt at all. Race dogs, for the practice of veterinary neurology, some animals are more important than the others. Like race dogs, race horses, during running, race horse and race dogs may injury, especially focal injury, may they have. So we searched at the carpal tunnel region of the dog. Anatomically, radiologically, and electrophysiologically. In different positions, So we forced supination of the animal, then forced pronation, and different positions of the head, and watched for the changes that the parameters detect. Then we, through anatomical classical dissection, observed the changes visually at the cadaver. And when necessary, cross-sectional examination we did. Here you were seeing this median nerve with blue, arteries and veins nearby. At the carpal region, hyperextension, as you see at this picture, hyperextension. Yes, was better to all. Hyperflexion was the bad. And this one is neutral position. Same principle as in the children cases. Dogs need time because the subject is under general anesthesia. You have to do it so very quickly. There was no time for any wrongdoing. Yes, ulnar nerve motor study, ulnar F waves. Yeah, regulator stimulation of the ulnar nerve. Yes, we're very similar, as you see, like humans. At the elbow, ulnar nerve, surrounding adipose tissue, as in humans, sometimes big trouble for the animal, like focal neuropathies. Yes. Different, we want to show how different positions for all animals affect the electrodiagnostic parameters. Yes. From fossa axilla, stimulation of the radial nerve and recording from the triceps muscle. Yes. You are seeing the classic dissection of the radial nerve here. Yes, suprascapular nerve, stimulation from fossa axilla and recording from the supraspinatus muscle. Femoral nerve, same as. From stimulation from spatium femorale. Yes, cross-sectional anatomy. Perineal nerve and classical dissection. Look at the tiny perineal passing here. Tarsal, at the tarsal tunnel, the tibial nerve stimulation from distally. Yes, and classical dissection or recording potential. We did some observations of dog tarsal tunnel. We compared the electrodiagnostic parameters for different positions, extreme positions, forcing the range of motion, and also magnetic resonance studies. As you see, its classical dissection counterparts, the passages of the nerves with arteries and veins, very traumatized region. They call critical zone. They easily be crushed or stressed or under pressure by surrounding tissues. see tiny complex of artery, vein, and nerves. Yes. And how it changed with the position? How it changed? Hyperflexion generally did much effect in bad ways on the electrodiagnostic parameters. Any idea of that picture? Do you understand what was doing here? Yes. Bulbocavernosus reflex study in dog from the dorsal penis nerve, here stimulated, and then recorded from the bulbocavernosus muscle, and very easy, no time dependent, in a very quick time you can handle this, and much information about the sacral region of the dog, as you know. The bulbocavernosus muscle is here in sharp section, and the bulbocavernosus reflex, male dogs approximately 24 milliseconds later, and female dogs 22 milliseconds. This is female dog, stimulated from the clitoris and recording from the sphincter arms. In ducks, as I said before, there are much variation, anatomical variation than the other species. So this is also same for the facial nerve and trigeminal nerve at the cranium. But blink reflex, the station of blink reflex is also easy for us. Not much time dependent. Yes. And by stimulation of the facial nerve, recording from the orbicularis oris and orbicularis oculi muscles. And normative data similar to human children. Very simple. Thank you for attention.
Thank you for the excellent talk on this topic, which most of us, I think, are very far from. Is there a question to conclude? Yes.
Thank you for this interesting presentation. I'm just wondering whether you have any experience with middle EMG in dogs, I think, in disease states such as myopathies or anterior horn diseases.
No, because of need of anesthesia, so volitional muscle activity we can't observe. With unrest dog, it's hard but not impossible. With experienced and quick electrodiagnostician can success.
Yeah, okay. Actually, we did have some experience about that, and when you are performing middle EMG in dogs, you know, their pain threshold are higher than the human being, I think. And in case of myopathy, you see clearly early recruitment. And in case of lower motor neuron involvement, as a result of degenerative disorders that they may have also, you see lots of denervation activity ongoing.
But it depends on sometimes which breed you use, which breed of dog, because between dogs breeds much differentiation about the latency of the nerve. You may have a big dog, the hound, or a very small chuchu dogs. So, to my experience, how the small the dog, much the pain you have here when picking the needle in it. But it's possible. Same as pediatric EMG. Very similar, very.
Can I just add
experience on myasthenia in dogs, golden retriever and Labrador. I've done 7 dogs with voluntary jitter analysis from their deltoid.
Jitter?
Yes, and that worked very well, and we got the diagnosis in these dogs. It was really nice. And another thing is that we did some recordings of horses with a special disease. They had a lot of complex repetitive discharges, and they don't jitter at all. And since they were horses, we call them stable potentials.
Is there another question? Thank you. And before closing this symposium, on behalf of the local committee, I would like to thank to all of you, thank to International Scientific Committee for giving an opportunity to us to organize this meeting, to all supporting companies, to organizing company K2, and special thanks to Eric for his trust on us. Thank you.
I take the opportunity to, on behalf of all of us, say thank you to this organizing committee and all that have been working with you. This has been the biggest meeting so far, and we don't talk about quantity, we also talk about quality. It has been a very, very high quality, and it's very intense. I've been impressed by the Turkish colleagues working here in the evenings, so that has really been fantastic. Give a big hand to the organizing committee. And I would also like to thank K2. The K2, you know the logo with the blue K and a 2. It means actually the high peak in the Himalaya. And they have chosen this because that is an extra challenge to reach that top. And it needs teamwork to reach there. And therefore they chose this logo. And I think you have reached the top. So we thank Evren Turan and his big team that you brought us up to the end point. Thank you very, very much.